In this video, we want to find the area of the region bounded by the line y equal to x minus 1 and the parabola that opens sideways and has the equation x equal to 3 minus y squared. Now, the graph of the parabola x equal to y squared has vertex at the origin and opens to the right. Now, putting a negative in front of the y squared here makes it go the other way, opens this way to the left. And then the plus 3 here makes it move over 3 places to the right. That's how we get the vertex over here. Then the line, we can plot the point x equal to 1. I get the point here 1, 0. X equals 0, I get 0, negative 1. That's this point here. Draw the line. And then we can find these 2 points of intersection here a couple of ways by substitution here. I replace this x right here by 3 minus y squared, and I still have the minus 1. Solve this equation for y. Let's bring the negative y squared over. I get y squared over here plus y. It's just a minus 3 minus 1 is 2. Take it over, I get minus 2 equals 0. Solve this equation by factoring. This would be y plus 2, y minus 1. Set each factor equal to 0. We get solutions for this to be negative 2. Y can equal negative 2, so y can equal a plus 1. And then we can use those values to find the points of intersection of the parabola and the line. A couple of ways we can do it. Doesn't matter which one we plug it in here. We could plug it into the line of the parabola. Let's do it over here in the line. Put the 1 here for the y. Then solve for x, add 1 to both sides, we get 2. So y equal 1, x equal to 2. And then for the negative 2, we can plug it in this one also. Let's put negative 2 for the y. Bring this over to this side, we get x equal to negative 1. So that's how we get that point right there. So we have the points of intersection. So now we want the area of this region contained between the line and the parabola. That's it right there. And we have the option to use rectangular strips that are horizontal, like this. And then the width would be in the y direction here, this would be dy. So we'd be integrating with respect to y. Now if you go with rectangular strips, notice in this region right here, we have the top curve minus the bottom curve. That would work okay. But notice once we pass this point right here, it changes. So we'd have to use 2 integrals. So to avoid that, we just stay with a rectangular strip here. This, and we set up the integral then for the area using a horizontal rectangle instead of vertical. That way we only use 1 integral. And we can integrate it from, again, the y direction here. So we go from minus 2 to that point right there. Infinite number of horizontal rectangles, and then the integral will sum it up from minus 2 to 1. So we need the length of this horizontal rectangle. And again, the width is going to be dy, so we'll be integrating with respect to y. So it's going to be this length here minus the line. So this will be x here. Length of this goes from here to here, that'll be x to the line. But because we're integrating with respect to y, the x has to be in terms of y. And we have it in this case. So it's going to be 3 minus y squared minus, so this case, just the right curve minus the left. And the left is x again, but it has to be in terms of y. So this x, because it's the line, is x equal to y plus 1. If we were doing it vertically, it would have to be in terms of x because the variable of integration would be x. So here we just put minus y plus 1 dx. Then I'm going to follow up over here. Equal to area, integral from minus 2 to 1. So I'm going to have the minus y squared, and then I have a minus this expression here in parentheses, so it'll be a minus y. And then I got a minus 1. Distribute the negative, minus 1, and then a 3, it's a bit plus 2 here, dy. So again, in summary here, we use a horizontal rectangle, so we only need 1 integral. If you use a vertical rectangle, we have to use 2 integrals. And then we need the length. We need the length of this rectangle. So the length, again, when it's set up this way, it's the right curve, which is the parabola, minus the left, which is this line. So you just subtract this distance x, but it has to be in terms of the parabola. That's what we have, okay? X equal, and then minus, say we use this one over here. It's again this x minus x, but this x is with the parabola, and this x over here deals with the line. So we have to use, for this one, x has to be in terms of y plus 1. The x to the far right is in terms of y also, but that's the parabola. So that's how we get this, the right curve minus the left. When you do using the vertical rectangles, it's top curve minus the bottom. There it has to be in terms of x. And now we just integrate here with respect to y. So add 1 to the 2, we get 3, and then divide. For the y minus y, add 1, we get y squared over 2. Integrate with respect to y for the 2, we get 2y. So we get minus y to the third over 3 minus y squared over 2 plus 2y. And then we evaluate the limits of integration here. We're just going to go from negative 2 to 1. So we evaluate the expression at 1. So put a 1 there, that gives us a minus 1/3. Put a 1 there, we have the y squared, that gives us a minus 1/2. Put a 1 there, we get a 2. So this gives us a minus 1/3. And then we get a minus 1/2. Then I get a plus 2. And then we subtract the value of this expression at negative 2. We put a negative 2 where the y is, be negative 2 to the third. That'll give me an 8 over 3. Negative 2 here will give us a 4. Divided by 2 is 2, and then the minus. This will be minus 2. Minus 2 where the y is here. Minus 2 times 2, that's a minus 4. So again, plug it in 1. We get minus 1/3, minus 1/2, plus 2. And then you subtract the value at negative 2. So plug it in negative 2, where the y is. Get 8 over 3, minus 2, minus 4. So then for this one here, common denominator here is 6. Put this over 1. 3 into 6 is 2, times the minus 1 is minus 2. 2 into 6 is 3, times the minus 1 is minus 3. 1 into 6 is 6, times 2, that's 12. I've got a minus here, and that's what we have in the parentheses here. Common denominator is going to be 3 here. So 3 into 3 is 1 times 8, this will be 8. 1 into 3 is 3 times the minus 2, minus 6 here. 1 into 3 is 3 times the minus 4, so minus 12. So let's add this then, minus 2, minus 3 for this one here is minus 5 and 12, give us 7 over 6. Get a minus here, 8 minus 6 is 2, minus 12. This would be 3 here, minus 10 here, over 3. Then get a common denominator there, so multiply this by 2 and 2 here. And this cancels that out, plus, so this would be 20 over 6. This would be 20 and 7 is 27 over 6. Got a common denominator here, over 6. And then reduce that down, divide by 3, we get 9 over 2. So the area of the region in question here is 9 over 2 square units, since we're dealing with area. Thanks for watching. We'll see you next time.